This is the Unit 1 Review key video. Before we start the problems, quick reminder on the top here, we have the quadratic formula, which you might need for later on. We have the three different formats that you can see for the quadratic equations. All right. If you're going through this video, you're like, I still don't know what I'm doing, you still have questions, please make sure you get to a Zoom meeting before the test on Friday. All right, simplifying expressions. What we're going to do is simplify each one of these expressions to see if they are the same. Okay, so for the first one, we have x minus 1 quantity squared, so we're going to multiply that times itself. Okay, so we can get rid of that 2 because we're multiplying x minus 1 times itself. So we have x squared, we have negative x, negative 1 times x is again negative x, negative 1 times negative 1 is positive 1. We combine the like terms, we get x squared minus 2x plus 1. So that is the first expression we're looking at. The second one, we have to multiply the 2 times x squared, gives us 2x squared. 2 times negative x is negative 2x. Then we have another negative x squared, and a plus 1. So we look to combine these terms. 2x squared minus x squared is just x squared, minus 2x plus 1. So you can see that these two are the same. Yes, they are equivalent. Number 2, just says simplify. It doesn't say check equivalency. So we're going to do our little rainbows here. So 3x squared times 2x is going to be 6x to the third. When you're multiplying bases with exponents, you add the exponent. So it's 2 plus 1 is 3. 3x squared times negative 5 is negative 15x squared. Negative 2 times 2x is negative 4x. And negative 2 times negative 5 is positive 10. There is no other things to simplify or combine, so that is your answer. Next, we have two expressions here. All right, got to say if they're equivalent. So we're going to do the 5 times y, 5 times negative 3. Let's zoom in a little bit. So you get y squared minus 3y plus 5y minus 15. We can combine the two y's in the middle there, so we get y squared plus 2y minus 15. So that is one expression. I'm going to check it against the other one. We have y plus y, which is 2 y's. We have plus 15, which you cannot combine because it doesn't have a y on it. And then plus y times y, which is plus y squared. We rearrange this so that they are in the correct order. You have y squared plus 2y plus 15. And you can see now that these are not the same. This would be a no, because one has negative 15 and one has positive 15. Okay. Now this one, you're given an expression, you want to compare it to the other one. So you basically got to do simplifying expressions for all these problems. Some might have more work than others. Apparently oh, no, that's different. Okay. So we're going to do our little rainbow thing. So 2n times 3n squared, 2n times negative 2, 1 times 3n squared, and 1 times negative 2. So 2n squared times 3n squared is 6n to the third. 2n times negative 2 is negative 4n. 1 times 3n squared is 3n squared. And 1 times negative 2 is negative 2. Okay, now we should put these in the correct order. So we have 6n cubed plus 3n squared minus 4n minus 2. So this is what we're going to compare the other expressions we have with it. So right away we can see that A, this does not even come close, so this is a no. Okay. The next one, we have to actually do some math with it. You're going to multiply n squared times those two numbers inside the parentheses. So you have 3n to the third minus n squared plus 6n minus 6. All right, there is no other things to combine like terms-wise with letter B. So that's it. And then if we look at our first equation, the 6n cubed part, those obviously don't mix or match, so those are a no. C is also a no because that's obvious. Lastly, probably going to be D if we're doing this, but let's just show you the work. So 3n times 2n squared, plus it also says algebraically show your work. So we got 3n times 2n squared is 6n to the third. 3n times n is going to be 3n squared. Negative 2 times 2n is negative 4n. And negative 2 times 1 is negative 2. We can see if we look up at that back up at the top, those two things are the same. So we do D as a yes. Excuse me. All right, so that is equivalent expressions. Next we move on to patterns, whether it's linear, quadratic, exponential, or none. Okay. So for number 5, we're always looking for exponents. So this exponent is x, so it must be an exponential. Okay, and why? Because its exponent is x. That is why it is exponential. And number 6, the largest exponent is 2, so this must be a quadratic. And why? Because the largest exponent is 2. That's why it's a quadratic. And finally, number 7 for this section. All right, although it doesn't say it, it is a 1 for an exponent, so this is a linear. And the reason being is because the largest exponent is 1. And that's why it is linear. All right. Key features of quadratics. So these are the formats that we saw at the very top of the page. All right, so this number 8, there are 2 factors. All right, so there's a factored format. All right, is it concave up or down? We can tell by the number out in front is a positive, so this is concave up. All right, what the x-intercepts? You take each of the factors, so x minus 8 and x plus 10, set them both equal to 0 and solve. Okay, so you will have, you're going to put these as points. So you're going to have 8 comma 0 and negative 10 comma 0. Okay, you have to solve both the factors, set them equal to 0 and solve them. And then you can find your x-intercepts. Please make sure you write them down as points because they are x-intercepts. Number 9 is the graph concave up or down. So we look at the number out in front. It's negative, so this is going to be down. Okay. What is the vertex? We're looking for h comma k. The h comes out, it changes sign, so it becomes positive 8 and then 3. So again, the vertex is a point. We're going to write it as a point. And lastly, what is the axis of symmetry? It's going to be an x equals equation. It's going to be the same number as your x value of your vertex, or your h value. So x equals 8. Lastly, we have a standard format quadratic. It's a concave up or down. Again, we look at the number out in front. It's a positive 8, so it's going to go up. What is the y-intercept? You look at the last number, and that is the number that it goes where it goes through the y-axis on the graph. So you're going to write this as a point, 0 comma negative 1. And that is the different formats. Next, we're going to use this information about the different formats to help us in modeling this with a graph. Okay, so what you want to do for these problems is look at the characteristics of the graph that you can get from the equation, and then see if you can match them up to the specific graph and see if it actually works, or it could work. It doesn't have to be exact, but it can have things like if the equation says the graph's supposed to go down, the graph goes up, well, that doesn't work. Okay, so let's see what we got. So the first one, we have a vertex format. So the vertex, I'm going to put as V, is going to be 1 comma 2, and the graph's going to be going up. Okay, so if we look at our 2 graphs here in blue, all right, 1 comma 2, this could be this vertex right there, and that graph is going up, versus the other graph is going down, so it definitely wouldn't be that one. So we can put A for that. Let's check the next one. The vertex for this graph is going to be negative 5 comma negative 3. Again, make sure when you take the h out of the equation, it becomes the opposite of what it is in the parentheses. All right, and this graph is, again, because the 2 is positive, it is going up. So you can only look at the graph on this first graph here, but its points is both positive, and the point for the vertex in this equation is both negative. So that's not going to work. So that's not going to be in either graph because the other graph that we're using on the other side is going down, and this equation has to go up. For part C, our vertex is 3, negative 2, and it is going down because the 2 in front of the parentheses is negative. That means it's going down. So look at the down graph over here. Can this be 3, negative 2? Well, 3, negative 2 would be over here someplace. So it is definitely not that graph. All right, so, and it's definitely not the other graph because it's going down and not up. So C would not work. Finally, we got to D. So, oops. The vertex is negative 3, positive 2. All right, and the graph is going to be going down because, again, the 5 in front is negative. So when we look at our going down graph, negative 3 and 2. Well, negative 3, 2 would be up here. Although it is going down, the vertex is not in the right quadrant of our coordinate plane, and thus D won't work for either one either. Okay, so the only one that does work is A. 12 is much the same thing, but this time we have different types of quadratic equation setups or formats. We have a vertex, we have a factored form, we have another vertex, and we have another factored form. So we do the same kind of thing and check to see if it works for this particular black graph. Okay. So again, we look for the vertex. The vertex is negative 2, 1. And the graph, since it's positive in front of the parentheses, is going to go up. So we look to see if that, well, that doesn't work because that graph goes down. So that one's not going to work. For B, in this case, we're looking at the factored form, so we're looking for the x-intercepts. If we solve both of these factors for x, we're going to find out that they are for 4, 0, and 3, 0. And the graph, since it's negative out in front, is going to be going down. Okay, well, our graph is going down, but the points on the graph of 4, 0, and 3, 0 should be someplace over on this side of the y-axis, and the graph is not. So again, B will not work. All right, for C, again, we have a vertex form, so we're going to find the vertex. Vertex would be negative 4, 2. Because that's a negative, it's going to be going down. All right. So negative 4, 2 would be up here, so that works for the vertex, and it is going down, so that is a viable option. So C could work. Let's do the last one here. All right, we have a factored form, so you're going to have 2 x-intercepts. You're going to have negative 2, 0. You're going to have negative 3, 0. Because this is negative, it's going to go down. So again, we can look at this. Negative 2, 0 could be here. Negative 3, 0 could be here. The graph is going down, so that is a possibility that can also be the equation. We're going to circle D as well. So we have C and D for that particular one. All right. Looking at 13, again, we have a vertex form, so the vertex is going to be 3, negative 2. All right, and the graph is going to be going down. So we got to see if we can find out. Now these are a little bit more specific. We got to find out, since it gives you more of a grid, you can actually find out if the point is correct. So 3, negative 2 going down. Let's see. What we'll first do is cross off anything that's going up because this equation should be going down. So this one's off, and this one's off. All right. So the other two work as far as the directionality. They are both concave down, but now got to match the point. So since it's 3, negative 2, this graph here is at 3, negative 2, so B would work. D is at 3, positive 2, so this would also not work. So B is your only answer. All right, moving on to solving quadratics. All right, now when we're doing solving quadratics, there's a bunch of things you can do in terms of like a system to go through to see which type of quadratic it is and which is the easiest way to solve it. The first thing you do is try to take out a greatest common factor. If that has a greatest common factor, take it out. makes the equation simpler to solve, and then go from there. Okay, if there's no greatest common factor, the first thing you want to check then is, can you solve it, factor it using the 5 steps to factoring? That's the easiest factoring method. Okay, if the 5 steps to factoring doesn't work because it has a term in front of the x squared, then you go to the next step, which is advanced factoring. So you could do one of two options. You have factor by grouping, or you could do the bottoms-up method. Doesn't seem factorable. Okay, then you can do the next thing to see if it is a solving using square roots problem. And lastly, if none of those work, then you can always put it in the quadratic formula. So, let's start these out. Number 14, looks like there's no greatest common factor to take out, but it looks like you could do a 5 steps to factoring. Let's try it out. So step 1 is put the x's in. Step 2, drop the first sign. Step 3, what times a positive gives you a negative? That would be a negative. Factors of 3, there's only one of them. There's 3 times 1. Put the biggest number first, 3 and 1. And that does work to give you 2. So then we solve them because it said equal to 0. So x plus 3 is equal to 0. X minus 1 is equal to 0. X will equal negative 3 and positive 1. For 15, before we can start doing any of the things we want to do on our checklist, we have to get everything to the same side. Now, it might seem like we want to take the 6x squared and subtract it to the other side, but I actually don't, because I don't like my first terms being negative. So I'm actually going to add 30x to the right. I can still write it as 6x squared plus 30x equals 0, because I'm just flipping everything around the equal sign after I move the 30x over. So now my 6x squared is positive, and it's much easier to work with. So I guess I'll go through these steps for solving quadratics. The first one is, can you take out a greatest common factor? And in this case, you can. You can take out a 6 and an x. What's left over is x plus 5. Okay, and what you'll see here is there's nothing else to factor because it's already been factored completely. So there's no 5 steps, there's no advanced factoring. You can take the factors that you have here, the 6x and the x plus 5, set them both equal to 0, and then solve them for x. For the first one, you're going to divide by 6. 0 divided by 6 is 0. The second one, you're going to subtract 5, so you get negative 5. And those are your 2 answers. For 16, there's a couple ways you could do this. If you go through the checklist of how to do quadratics, first of all, you look for greatest common factor. There is nothing to take out of this. But this particular problem gives you a lot of different options. You can do 5 steps to factoring. You can do solving using square roots. All right, because I know there's a difference to 2 squares problem, which we have mentioned in class before. I know that it's going to be just x and x, and the square root of 36 is 6, so I'm going to put that in both spots. One's going to be positive, one's going to be negative. And that is the factorization for this problem. Okay, if you were to do solving using square roots, you would have added 36, taken the square root of both sides, and you would have gotten x equals plus or minus 6, which is what your answer is here. Negative 6 and positive 6. After taking both sets of factors, setting them equal to 0, and solving for x. All right, here again, we have to get everything on the same side, so we're going to have x squared minus 6x. We're going to subtract the 7 to the other side. You get minus 7 equals 0. Okay. Again, this looks like a 5 steps to factoring, so we have x and x. Our factors of 7 are 1 times 7. Okay, so if we drop the first sign, we get negative. What times a negative is a positive, or what times a negative is a negative? That would be a positive. The biggest factor is 7. We'll go put 7 first and then 1. Negative 7 times 1 is negative 7. Negative 7 plus 1 is negative 6, so that does work. we set both factors equal to 0 and solve. So x will equal positive 7 and negative 1. Moving on to 18. Okay, again, it might look easier to just subtract the x to the right, but I don't want to have my x squared terms to have a negative in front of them, so I'm going to actually add x squared to the left and add 8. We'll get x squared plus x plus 8 equals 0. Now this looks like a 5 steps to factoring because you can't take out a greatest common factor. But I know for a fact that when I find the factors of 8, it's going to be either 1 times 8 or 2 times 4. And none of those, when you subtract them, will give you 1 for the middle. So this is not factorable. So instead, we're going to have to put it in the quadratic formula. So when we do that, all right, the a value is in front of the x squared, which is 1. The b value in front of the x is 1. And the c value is 8. Again, the quadratic formula is at the very top of the page of the review packet. So if you don't remember it, check up there. I'm going to put the values in. We have negative 1 for negative b, plus or minus the square root of b squared, which is 1. Notice I put it in parentheses just in case it was negative. Minus 4 times a, which is 1, times c, which is 8. All over 2 times a, which is 1. Now, this problem does bring up an inconsistency that we haven't really dealt with in class at all. And that is, when you multiply the stuff inside the square root, you're going to end up with negative 31 inside the square root sign over 2. Now, we haven't talked about imaginary numbers as far as I know, so we're not going to start now. Technically, you take the negative sign out of the square root sign and put an I in front of it. All right. If you got to this point, then you should know what you're doing. So if you have another different quadratic formula problem in the future on the test, I feel confident that you'll be able to do this question correctly and not have any problems with the negative sign inside the square root. Because technically, you're not supposed to have negative signs inside your square root. For now, we're going to leave it, though. Number 19. Okay, again, you go through the greatest common factor. There is nothing to take out that all 3 terms have. You do 5 steps to factoring, but this has a 2 in front of the x squared term, so that doesn't work. Then you go to the advanced factoring. Okay, so factor by grouping or the bottoms up method. So let's see if that will work for this. We have 2 times negative 1 is negative 2. And the factors of negative 2 that combine to give you positive 1, it would be positive 2 and negative 1. So I like to do the bottoms up method recently just because I feel like it's faster and simpler. So I take these 2 factors and I take the denominator and make it of the factors, or sorry, the fractions. Let me back up. I take the 2 factors and make them fractions, and the denominator of our fraction is going to be the first number in front of the x squared term, which is 2. We can then reduce this. So 2 over 2 is 1 over 1. And then negative 1 over 2 does not get reduced, so it's just negative 1 over 2. You put an x in the bottoms and bring the bottoms to the top to make your factors. So you have x plus 1, the first one, and 2x minus 1 for the second one. So those are our factors. We can then take those factors, set them equal to 0, and then solve for x. We'll get negative 1 and 1/2. All right, and that is the quadratic equations. Next, evaluating functions. This caused some undue issues on our last test that could have easily been fixed had you actually, if you got them wrong, you actually went back and looked at the video and saw, oh wait, I wasn't supposed to do that at all. All you're doing is you're putting these values given the function into the function itself. When it says p to the p of negative 4, you're putting negative 4 in for the x term, but only of the function, not of the introduction to the function. So it looks something like this. Doing 5 times negative 4, and the absolute value of that. Well, 5 times negative 4 is negative 20. And the absolute value of negative 20 is positive 20. You're not multiplying it by -4 after you get to that part. All right? You're never putting it into this part of the function. Okay? M of -3. So you're putting -3 in for the x value of the function m of x. So you have 12 plus 2 times -3 squared. After this, it really kind of just turns into a calculator problem, but we'll go through the steps just to make sure. -3 squared is going to be positive 9 times 2 plus 12. 2 times 9 is 18 plus 12, which gives you 30. If you're doing this in your calculator, make sure you put the -3 in parentheses before you square it. If you don't put it in parentheses and you square it with a -3, it's going to give you -9, which is incorrect. You've got to make sure you put that negative number, and actually you should just, as a habit, when you're doing these types of problems, the number that you're putting in should always be in parentheses when it gets into the equation, into the function. Okay. Here we have 2 times m to the m of 4. So we're going to do 2 times 12 plus 2 times 4 squared. Okay. Now rather than show you the steps, which I don't really need to see, if you show me that work that says, hey, I know where the thing goes, I know how I understand how it works, just give me the number. So you have 2 times 12 plus 2 times 4 squared. Oh, I put it in wrong. 4 squared times 2 plus 12 times 2. There we go. I get 88. So just as a refresher, I did 4 squared first, which gives me 16. I did 16 times 2, which is 32. 32 plus 12 is 44, and 2 times 44 is 88. All right, now here we have two different functions that we're combining together. So we have k of -3, so we're going to put -3 in for the k function. So 6 times -3 minus m of -1. 12 plus 2 times -1 squared. So notice how I set it up. I put the whole m function in parentheses because I'm subtracting it. And I put the numbers that are supposed to go into the function in parentheses. So let's start here. 6 times -3 is -18. Minus -1 squared is 1. 1 times 2 is 2. And 12 times 2 is 14. I'm going to put it in parentheses just to be consistent. -14 minus 19 is going to be -32. And then we're done. All right. Now we have k of 1, so 6 times 1 plus p of 3. So we have the absolute value of 5 times 3, just like that. So 6 times 1 is 6. 5 times 3 is 15. The absolute value of 15 is still 15. So 6 plus 15 is 21. F. M of 0. So we have 12 plus 2 times 0 squared. It says divide, so I'm going to make it as like a fraction. Okay? Dividing and fractions are the same thing. If you see 1/2, it's 1 divided by 2. Okay? We're going to do the k function, so 6 times 2. So let's do the top first. 0 squared is 0. 2 times 0 is 0, and 12 plus 0, excuse me, is 12. Divided by 2 times 6 is 12. 12 divided by 12 is 1. Okay, last one of evaluating. We have p of -2, so we have 5 times -2, and the absolute value of that, plus k of 5, so I'm going to put that all in parentheses, 6 times 5, minus m of negative 3. So I'm going to put that, again, the whole thing in parentheses. 12 plus 2 times negative 3 squared. So this shows you the work of how you're supposed to set it up. Now you guys got to do the math. So 5 times negative 2 is negative 10, but the absolute value of negative 10 is positive 10. Plus 6 times 5 is 30, minus negative 3 squared is positive 9. 9 times 2 is 18, and 18 plus 12 is 30. So we have minus 30. Well, 30 minus 30 is 0, so your answer is just 10. Okay. Next, we got quadratic equations. Now, somebody in my third period class pointed out that the numbers for 22 are the same as 21, so I let them pick. So we are using 3 and 7 and 2 and negative 5 for this second problem of this. So for what you're doing with these is you're using the vertex format, y equals a times x minus h quantity squared plus k, and you're putting the values of these points into your equation where they belong, solving for a. Once you have a, you can rewrite the equation with the a value in it. Now we're talking about maximum point. We might not have touched on this, but maximum point in a quadratic means the graph is going down because there is one point at the very top that is the maximum. That means that this 2 comma negative 4 is your vertex, h comma k, and the other point is just x comma y. Now that we've labeled these points, we can put them into our equation. Y is negative 1, a, which we don't know yet, x is positive 1, minus 2, quantity squared, minus 4. Okay, now what we're going to do is we're going to solve this for a. I'm going to add 4 to both sides, which gives me 3 equals a. 1 minus 2 is negative 1. Negative 1 squared is positive 1. Divide by 1, a equals 3. So now what we can do is we can put the equation back together with the h and k values, and now we have our a is 3. The x and y will become x and y's. So y equals 3 from what we just found out, times x minus 2, quantity squared, minus 4. So the only thing we have in our final answer is the h and k and the a. All right, let's try that again with number 22. Again, your maximum is 3 comma 7, so this is your h and your k. This is your x and your y. So your y is negative 5 equals a times the x is 2 minus h, which is 3, quantity squared, plus 7. Subtract 7 because we want to solve for a. Gives us negative 12 equals a times 2 minus 3 is negative 1. Negative 1 squared is 1. Divide by 1 on both sides. A is equal to negative 12. Now we've got to rewrite our equation with our a value, our h, and our k. Y is equal to, a is negative 12, x minus 3, quantity squared, plus 7. There we go. That's it. Okay. Only got a couple more things to do. Now, it was funny on the formative, a lot of people did the word problem, which I would think most people wouldn't want to do word problems. And then they said they couldn't do the quadratic equation writing problem, except the word problem is a quadratic equation writing problem. So the other thing that we had problems with on these word problems is the drawings. Okay, on the test, these drawings count for 2 different standards. One, can you draw and label everything so that it isn't correct? It looks correct. We're not grading you on your artistic ability. And then 2, can you take that information and put it into an equation? So here we have a rocket, so I'm going to draw a quick rocket. Got a platform it's sitting on, and the platform is 2 meters high. Okay, when the rocket takes off, reaches its maximum height, and this is where we had some problems. Maximum height is 50 meters. Height means tall, means up. Okay, horizontal is like if you're laying down in bed. Okay, it means left and right. Okay, so that horizontal distance is 20 meters. And in the formative that we took, a lot of people switched those around. They put the 50 as a horizontal and the 20 as the height. And that's just not the case. Okay, so now what this means is this vertex is 20, 50, x, y. So this is your vertex, h, k. And your point over here at 2 height is going to be 0, 2. This is your x and your y. So now it becomes just like the problems we did the last two, and 20 and 21 and 22. Our y value is 2. Our a value is unknown. Your x value is 0 minus h, quantity squared, plus k. Oh, sorry, I made a mistake there. The y value is 2. There we go. So I'm going to solve for a. I'm going to subtract 50, get negative 48. Goes a. And then negative 0 minus 20 is going to be negative 20. And negative 20 squared is going to be 400. We divide both sides by 400. And using your calculator, you can reduce this fraction. Negative 48 divided by 400. Then you hit math, enter, enter. And you get negative 3 over 25. So please make sure you reduce that fraction. Now that we have our a value, we can put it back in the equation. Y is equal to negative 3 over 25 times x minus 20, quantity squared, plus 50. Okay, so on these types of problems, you're grading 1 is your picture drawn correctly with the values in the right spots, and 2 is your equation correct. Did you show the work? All right, 24, same idea. Firework is projected vertically into the air. So this time we have another little, there we go. So we're going to project this or shoot it in the air. It is 3 meters off the ground. Okay, and when you shoot it off, it's going to be maximum height. So the height is 98. And the horizontal distance going left and right is going to be 15. So this point is an x, y is going to be 15, 98. This is your h and your k. On this point over here at 3, it's going to be 0, 3. This is your x and your y. So again, we're looking for the graph. Sorry, not the graph. The drawing. Does it make sense? Or did you put the stuff in the right spot? And now we can make our equation. So our y value is 3 equals a, which we don't know, times x, which is 0, minus h, which is 15, quantity squared, plus 98. All right, so we start solving. So we have subtract 98, get negative 95, equals a. Negative 15 squared is going to give you 225. Divide both sides by 225. All right, here again, we want to reduce our fraction if we can. Your calculator will do it. If you're not sure, if you don't have a calculator, you have the Calculate 84 app on your iPad, or should have. You can use that as well. So negative 95 divided by 225. Hit math, enter, enter. You get negative 19 over 45. And now we make our equation. Y is equal to negative 19 over 45 times x minus 15 quantity squared plus 98. Okay. The last two things are from the first unit test. They're going to be showing back up on this test. All right. All you have to do is go into your calculator, hit the y equals button. You plug in this equation just like it looks. So your parentheses, 3x plus 2, end parentheses, quantity squared minus 10x plus 4. If we were to graph this when you hit the graph button, let's see what it looks like. It's going to be way up here. Look like this. Doesn't have to be exact, it's just a sketch. But we want to find the y-intercept, so you're going to hit the second and graph again, and it gives you a table of values. In this table of values, you're looking for one specific value. You're looking for where the x value in the first column is 0. Because whatever that is, that number next to it, which is 8, is going to be your y-intercept. Okay? So you write as a point, 0, 8. For 26, do the same exact thing. Got to change out the equation. We got 25x minus parentheses x plus 8, close parentheses, quantity squared, plus 38. I'm going to graph it real quick to see what it looks like. Looks like this. We do the second and graph to get the table. Look at where 0 is on the first column. Under x, it is 0, negative 26. And thus we are done. So these are all the things that are going to be on the test. Please try it out before you watch the video. Well, or you already watched, if you're at this point in time, you already watched the video, so never mind. But make sure if you're not sure how to do something, you come to the Zoom and ask questions before you take the test.